everyone. Hi everyone. For today's lesson, we are going to expand on trig ratios. In the last lesson, we learned how to set them up using sine, cosine, and tangent with our acronym to help us, SOHCAHTOA. Now today we have two goals for the lesson. First, we're going to learn how to use the calculator with our functions. And then from there, we're going to learn how to solve for the missing side lengths in right triangles. So we can use sine, cosine, and tangent to either solve for the sides or the angles when we're working with right triangles. And today our focus is on the side lengths. So the first thing that we need to take note of when we are working with the calculator is the mode that we need to have it in. So if you look at the directions in the top right corner with the star, it tells us the step-by-step directions of how to get our calculator in the proper mode. So we're going to go over to the calculator. If you don't have one, you can access one online, as I did. So you're going to go to your calculator, and then you're going to click on Mode, which is right next to your second key. And if you look down where it says radian, you're going to go use the down arrow 2 times to radian. You're going to use the right arrow and select degree. You want to check this every single time that you get ready to use your calculator, because if it is in degree mode, you will get incorrect answers. So it's just to be safe every time to make sure that we have it in degree mode. Once you have that, you can click enter to select it, and then second mode to exit out of it. Now our calculator is in degree mode and it is ready to go. So we're going to use the calculator to approximate sine, cosine, and tangent with different angle measures. So first we're going to approximate the sine of 30 degrees. So to do this, we just click on sine on the calculator. Here's our sine, cos, and tan that we're going to use. So we're just going to click on sine, type in 30, close parentheses, and enter. And that is all we have to do. So we're just going to round all 6 of these problems to the 10th place just to get used to using the calculator. So for that we get 0.5. So that's 5/10. Then for the next one, if we look at the cosine of 90 degrees, I'm going to just type cos 90, close parenthesis, enter, and I get 0. And then the last one, we're doing the same thing. Tangent of 70 degrees, I go to tan 70, close my parenthesis, and enter. And this one, I get a nice long decimal after, but we're just going to the 10th place, so I'm going to round that to 2.7. And then you can go ahead and plug in the next 3 problems. And then once you do that, for the sine of 83 degrees, that should round to 1. I believe you get 0.99 and then some other numbers following. For the cosine of 56, you should have gotten 6/10. And then for the tan of 48 degrees, you should have gotten 1.1. So that is how we're going to use the calculator for these. And then moving on, now we're going to start finding the side lengths of right triangles. So the first thing that we always want to do is write down SOHCAHTOA. I'll write it this way. So that we can see our ratios. Just a quick refresher, sine stands for opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Again, I would recommend writing this for every single problem that we do. So what we're going to do here is find the value of each variable, and we're going to round to the nearest tenth, just like we did up above. And then the steps are given to us. So first we want to determine which ratio we're going to use, whether that is sine, cosine, or tangent, remember that is going to depend on where our reference angle and then the sides that we're given information for based off of that angle. And then we're going to set up an equation that models the given situation that we have. And then lastly, we solve for the variable by isolating it. So to begin, I'm just going to write SOHCAHTOA, as all of you should also do on yours. And I'm going to try to use the same colors that I did previously. So if I look at my reference angle, which is 52 degrees, I'm just going to mark that so I know where I'm working from. And then the easiest one to always mark is our hypotenuse, since it is going to be across from the right angle. So there's my H. And then we remember that when I can make an arrow through the triangle, that is going to be my O, or opposite. So in this case, I'm going to be using the OH, so that is sine. And that's OH. So the way that we set this up now is I'm going to do just what we had over here, whatever function we're using with the degree measure. So I'm going to take the sine of 52 degrees and set that equal to my ratio. So x is my opposite, and then 15 is the hypotenuse. And now we're ready just to isolate my x and solve for that side length. So in order to get 15 out of the denominator, I want to multiply both sides by 15. That's going to cancel out. And now I'm left with 15 times the sine of 52 equals x. And then when we look at our calculator over here, I'm going to type in exactly what I see. 15 times sine of 52, close parenthesis, enter. And we are rounding this to the 10th place, so I'm going to say this is x equals 11.8. And that is how we do this. So now for the next one, remember the first thing that we are always going to do is write out SOHCAHTOA. Then we can look to our reference angle, which is 37 degrees. And now I'll mark up my sides. So I see something across from the right angle. So we are working with a hypotenuse. Oops. And then I'm working with the side that is right next to the 37 degrees. So we are working with our adjacent side. So in this case, I'm working with my AH. So we're going to use cos. So that is A over H. Same setup as we did last time. I'm going to start with the cosine of my angle measure, which is 37 degrees, equals adjacent over hypotenuse. We already marked it to make it easier for us. So we're going to take the adjacent side, which is x, over our hypotenuse, which is 14. Again, we want to get rid of our denominator, so I'm going to multiply both sides by 14. So it cancels out, and now I have 14 times the cosine of 37 equals x. And then when I look at my calculator, that is 14 times cosine 37 is 11 point, we'll round it to 2. And there you have an example of solving using cosine. Moving along, we have 4 more. I know this gets repetitive, but we have SOHCAHTOA. My reference angle is 24. I don't see anything across from my hypotenuse this time. I can draw an arrow through the triangle to the other side where my 8 is. So that is going to be opposite. And then when I have a side that is touching or making my angle, my reference angle, that is my adjacent side. So in this case, I'll use purple. We're using tangent. So that is my opposite over my adjacent. So now we're going to set it up just like we did the other ones. I have tangent of 24 degrees equals opposite over adjacent, which is 8 over x. So this one looks a little bit different from the previous 2 problems because as you see our variable is in the denominator. So we're still going to follow the same process that we did before. However, we will just have one additional step in the end. So I'm just going to go ahead and multiply both sides by that variable in order to have no denominator. It cancels out and I'm left with x times tangent of 24 equals 8. And now I still don't have this isolated. Which is what I want to solve for. So I'm going to go ahead and divide the whole thing by tangent of 24. And then when that cancels out, I now have x equals 8 times tangent of 24. And you can plug this into the calculator just as you see it. 8 divided by tangent of 24, and then close the parentheses. So 8 divided by tangent of 24. And there you have your answer, which is 17.9. We'll round that up to 18. And then the next 3 problems, we are going to step it up a notch by using an x and a y variable. So for the first one, I'm going to set up SOHCAHTOA twice to see the 2 different ways that we're going to have to solve it. So I'll start with the x. So I'm going to mark my reference angle. The x is opposite. Here's my hypotenuse. And then my y is going to be the adjacent side. And I'm just going to start with the x. So that is going to be O over H. Forgot to put these in. Okay. So O over H is going to be sine. And then we can start solving. So I'm going to say the sine of 36 equals x over 10 multiplied by 10. And then I have 10 times sine of 36 equals x. And you should get 5.9. And then we can look at our y. So that's going to be a over h, which is cosine. And start plugging in our information. Cosine of 36 equals adjacent over hypotenuse, so that's y over 10. Multiply by 10 on both sides. 10 times the cosine of 36 equals y. And we get 8.1. And then we have two more. Okay, so our reference angle is 64 degrees. I have my hypotenuse. I have my opposite side. And I have my adjacent side. So I'll start with x again. That's going to be my a and my h, because we always want to look at where we have an actual value. So I'm going to be using the hypotenuse. So AH is going to be cosine. So I'm going to start with the cosine of 64 degrees equals x over 8 times 8 times 8. 8 times the cosine of 64 equals x. And I get 3.5. Then for the next one, I am working with OH, which is going to be sine. So that is the sine of 64 degrees equals y over 8. Plug it in. And we get 7.2. And last problem. We start with our reference angle, 48 degrees. I'm going to mark my hypotenuse, which in this problem we're solving for that. I'm going to mark my opposite, and I'm going to mark my adjacent. Once we have our triangle marked, then we can begin solving. So first I'll start solving for x again, and then wherever else I have my value given. In this case, my value is given on the adjacent side. So I'm going to use OA for this one, which is going to be tangent. So we're going to say that the tan of 48 degrees equals opposite over adjacent. So that's x over 8 times 8. 8 times tangent of 48 equals x. And that's 8.9. And then lastly, we are going to be using adjacent over hypotenuse for this one. So now we're using cosine. So the cosine of 48 degrees equals adjacent over hypotenuse. So that's 8 over y. Again, we don't want variables in the denominator. So now I have y times the cosine of 48 equals 8. Remember, this is one of those, whenever you have the variable in the denominator, you need one extra step for that. So we will be dividing in this case. So we're going to divide by cosine of 48 on both sides. Cancel that out. So now y equals 8 divided by cos of 48, and then you can plug that into the calculator. 8 divided by cosine of 48. And we get 11.95. We'll round that to 12. And there you have it. That is how we use the calculator with our three functions and how we solve for missing side lengths in right triangles using trig.